Alright, so today we will discuss ADAIR equation. And in ADAIR equation, there are about 3 of them. We have the one for dimeric, like the one we discussed today. We have for trimeric, and we have for what? For tetrameric. Okay, so for now we'll discuss the one for dimeric. So please pay close attention. Alright, now for dimeric, it means the protomer, which will represent the M, has 2 binding sites. So it will combine with the substrate and form what now? M2S. Are you getting it now? But since it has 2 binding sites, we can also take this M2S, bring it here again, M2S, and combine it with a further substrate, and it will now be completely saturated and form M2S2. Are you still there? Right, we take this first one, the rate constant of this one will be KB1. Are you still there? While this second one will take it to weighting KB2. Okay? Now, let's take out KB1. KB1 there is waiting. KB1 is what? Product over reactant. This is the product. So we take it to weighting M2S. Then the reactant are what? These are the reactant. Then also M2 and S. So my goal here is to make this one subject to the formula. So making this subject to the formula, making M2S subject of formula. So I'm using this one as shortcut, subject of formula. We have it waiting. M2S and then will be equal to waiting KB1 open bracket N2S. So we take this one to waiting. Let's label this one equation 1. You see that? Right, I will do the same thing for KB2. I'll do the same thing for KB2. I'm doing the board now. I'll do the same thing for KB2. Alright, let's go for KB2. Now KB2 from the equation I wrote before now is what's the product over reactant. Now our product was what? What was our product? Our product was M2S2, right? This was the product we got. All over the reactant there was what? It was M2S and S. So what I will do now, I will make M2S2 subject of the formula, just like I did for M2S the other time. Then also, so let's make this one subject of the formula now. So making this subject of the formula, I don't need to write it. Making this subject of the formula, we take M2S2 is equals to what? KB2, are you there? And into M2S and S. But we know what M2S stands for. Look at it here. This is M2S. So we substitute this into this. Can you get now? So substituting for M2S now. Substituting for M2S. We have it to be what now? We have it to be M2S2 is equal to what? KB2 M2S, right? And this is M2S. So KB1 what is left there? M2, then what? S. Then I think one S is still left here now, so we just put it. This S and this S. Let me just put this out, write it again for you. This is the last S I just put there. So therefore our KB or M2S2 now is equal to what? KB2 KB1 M2 S times S will give you what now? S squared. So this one become our equation 2. Are you still there? Alright. Alright, so the next thing we need to introduce now is the concept of fractional saturation. The concept of fractional saturation. Before we introduce that concept, we need to let me just find a way and write the initial equation we have before. And we said M2 plus S give us what? M2S, right? And here was KB1. Then M2S again combined with S, and it forms what? M2S2. This was our KB2. Now one thing we need to know is that this side we term it as waiting as the unbound. So here we call it what? Call this side what? Unbound protomer. While this side we tag it as what? As bound protomer. Are you there? Right. So having known this, the next thing I will say now is the fractional saturation. The fractional saturation represented with a symbol like this, Y, is equals to what? Bound protomer, or enzyme in case may be, all over bound plus unbound protomer. Are you there now? So what are our bound protomer? What is our bound protomer? These are our bound now, right? Okay. So let's take the bound protomer out now. So bound is equals to what? M2 plus M2S. Are you there? Sorry, this is the unbound side. This is the unbound. So we also need here unbound. Okay, this is the unbound. But our bound is this side. So bound now is equals to what? M2S plus M2S2. Now this one is unbound. This side is unbound. Eh? Before we continue, we need to introduce some numbers at this point. Now we introduce 2 here and introduce 1 here. The reason I will introduce 2 here is because this one is unbound, and that is to say it has 2 free active sites. Are you there? That is the fresh protomer. It does not have any substrate bind to it, so the 2 sites are empty. So we have to put 2 there. Then also, then once you put 2 here, just indicate 1 here because here there's only 1 more active site left. Then also, you have to put 1. Now, for simplicity's sake, once this first line of unbound now, this unbound line, it will be decreasing, while this side will be increasing. How do I mean? 2, 1. Here you start with what? With 1, 2. Are you there now? Alright, so let's quickly put this thing we've known now into this part of the equation and say that our fractional saturation Y is equals to what? Bound protomer. Where is the bound protomer? These are the bound protomer, which is what? 1 M2S. I will just put M2S. So M2S plus what now? Plus 2 M2S2. Are you there? These are bound, right? Now all over bound plus unbound. Now the bound plus unbound now will be what now? We need to add this a bit. So let me take the unbound first. Or let's take the bound and this will be. These are the bound, right? So M2S plus 2 M2S2 plus, let's come to the unbound now, plus 2 M2 plus this last one, M2 as M2S. If you notice, M2S, so we just M2S plus M2S give us 2 M2S. So therefore, instead of me to write the M2S, I will take this one off and just indicate 2 here. Then also, so this is the concept of fractional saturation. Let me just explain it again. Alright, so repeat everything. I said this is fractional saturation represented with something like Y bar, and this equals the bound protomer all over what? Bound plus unbound protomer. Okay? Then I said, look at this equation here. This side represents our unbound, while this side represents our bound. So I take it out. The unbound is what? M2 is M2 plus M2S. Okay? While our bound was what? M2S plus M2S2 plus M2S2. Alright. Now these 2, 1, 1, 2. How do we get them? This 2 stands for that this enzyme or protomer has two active sites that are yet to be bounded to a substrate. Why this one, yes, is telling us that it has just one active site left that is capable of receiving a substrate. And also, now come to this side, bound. This one here is telling you that it is bounded to just one substrate now. Are you getting it? Why this two is telling you that it's bounded to what? To two substrates. Is that not so? Alright, so that is the idea behind it. So fractional saturation is equal to bound. So this is the bound. Okay? So this is the bound. Then all over the total. Like I explained before, we now have 2M2S plus 2M2S2 plus 2M2. Alright? So let's move further now. Mind you, we already have an expression for M2S. In like manner, we also have an expression for M2S2. Okay? So what I will just do now, I will just substitute in what M2S means and what M2S2 means. Okay? So I will take this off. Alright, so what we need to do now is to substitute what M2S means and what M2S2 means. Now from equation 1, we know what M2S means, and we'll just quickly put it there. Fractional saturation Y is equals to M2S then was what? AB1 M2S. This was what M2S means from equation 1. Then plus 2. What does M2S2 mean? Let's put it. M2S2 means what? KB2, KB1, M2, then S squared. Okay? Then all over M2S2 again. So we have 2. I want to factorize. There's 2 here, there's 2 here, there's 2 here. I will take out one of the 2. Is that also? So M2S2, what does it mean? M2S, now what does it mean? It means KB1, M2S plus M2S, what does it mean? You can see it here already. So KB2, KB1, M2S squared. That also, then plus this M2. Okay? And the next thing we will do now is we factorize M2 from the top. Are you getting it? I will take out M2 so that I can also cancel it here at this bottom. So we have fractional saturation Y is equals to, I will take out M2. So we have M2 open bracket. What is left? KB1 S plus 2 KB2 KB1 S squared. Are you getting it? So all over, take out M2. We have 2 M2 open bracket. What is left there? KB1, we have S plus KB2 KB1, we have S squared plus 1. Remember we factorize M2, right? So that's why I have 1 there. So this one, take out this one. Then also, so that our final answer for dimeric protein ADAIR equation will be KB1 S plus 2 KB2 KB1 S squared all over, we have 2 open bracket KB1 S plus KB2 KB1 S squared plus 1. This is our final answer. So this is the end of the class for dimeric protein. Alright, I hope you find this useful. Alright, so in like manner, that's what we did for a dimeric protein. You can also do for a trimeric protein. Then also, likely also you can also do for a tetrameric protein. Okay? So talking about a trimeric protein, I believe you want to say M3. Then also, so M3 will combine with what? The substrate, and it will give you what? M3S. Then also, you will be tempted to call your what? KB1. You are correct to do that. Then I can also take this one again, M3S plus another S. It will give me what now? I believe you want to say M3S2. Then also, then here will be what? KB2. Now KB means binding constant, okay? Binding constant. Now, our protomer is not yet saturated. Alright, so I will take it again. M3S2 will combine again with one more substrate, and we have what? M3S3. Here will be what? KB3. So after written out this basic and the rest, from here we can continue our derivation. Just like I did in the previous one, we make some sort of formula, and from there you get it. Then all here will be what? All here will be what? Here will be what? Unbound, like we did before, while this side will be bound. Now mind you, when I was taking it to be now unbound, I did not include the substrate. I'm only focusing on the what? On the protomer. You understand? So subsequently in the next video, I will go into detail on this trimeric protein.